This video, we're going to put together the lower motor drive assembly. And here it is complete. This is the step cone pulley. Then it's sitting in a cradle, cast iron cradle. It's got bearings on either side of the shaft. This is the flywheel pulley that connects to the motor. Two horsepower, three-phase motor, double V-belts, mounting plate for the motor. This is the belt tensioning mechanism. All right, let's spin this thing up, see what it looks like. We'll see how it goes together. The first thing on the shaft are these clinch nuts that hold everything together. Washer, and then the bearing. These bearings are kind of an odd size. They're metric, 26 inner and 52 outer. I was a little surprised by that, but they seem to fit just fine. Here's a photograph of the labeling on the bearing. Then the bearing journal, and then the shoulder for the bearing journal. The next is that bearing retainer ring with 3 small bolts. Then we have set screws for the cone pulley. These set screws are 1/2 inch and they fit into a small hole in the shaft. These have a serrated edge on the very tip. You can see how they dig into the hole if you do it right. Cone pulley itself is in the middle of the shaft, and it's just a cast iron beast with 4 steps. Another retainer ring for the bearing on the opposite side, plus the bolts. Another bearing, same type bearing, the journal and the shoulder for the journal. Then comes the flywheel pulley that connects this shaft to the motor. And finally, there's a taper pin in the very end. This is the cast iron cradle for all of the stuff we just talked about. You can see where the bearings go in, the bearing housings there. And there are shafts we'll talk about later. First step is to put in these bearing retainer rings. 3 little bolts each. Don't forget the lock washer. Same thing on the other side. The next step is the first bearing. Now you could put these in your freezer for a couple hours. That'll help fit the bearing housing. But either way, just be careful as you set these in. I did it by just simply using a wooden handle on my sledgehammer and just tapped around the edge until it slipped in. It took a while, but it worked fine. I used a little block of maple just to make sure the bearing was seated all the way to the retainer ring, and it should be underneath the surface of that casting to allow plenty of room for the wheel you put on that side. So when you get done, you get this first bearing in, it should be below the surface on the outside and then seated firmly against that retainer ring on the inside. Okay, now we're going to mark the shaft location inside the cone pulley for use later. It seemed like this was a simple way to make this process a little easier. I just marked a line where the holes are for the set screws. And it's easier to find them later when you're trying to mount this thing inside the cradle. So just slide the shaft in. Then use the flashlight to locate the hole on the shaft for one set screw while you're tightening down the other set screw. Once this is set, then you can mark on the shaft the end of this cone pulley. It just seems like this is a lot easier than struggling to find it after you've got it in the cradle. Okay, we're about to slide the shaft and the cone pulley onto the cradle. You take out that nut again because the cone pulley needs to move on the shaft, otherwise you can't get it in here, and you can probably see why. So one end of the shaft goes through the hole that has no bearing yet, and then the other end of the shaft seats into the inner race of the first bearing you already put in. And if you put your shaft in the freezer for a couple hours, that'll help seat it easily. Okay, now that the shaft and the cone pulley is in the cradle, you can use those Sharpie marks now to tighten the cone onto the shaft. You need to have that cone tight against the shaft so that you can use the cone to flex and move the shaft as you're putting the next bearing in. You could probably get by with just tightening down one, but I'm doing both here. Here's what those set screws look like inside the cone. You can see they're just pressing against the shaft, and there's a lot. Now you can put the second bearing in. This is a little tricky because you are trying to slide the inner race onto the shaft and the outer race onto the housing at the same time. So you don't want to stress the bearing by pushing either one of them too hard. But you can use the clinch nut to work the inner race in, and then I just used a little block of maple to kind of tap the outer race into the housing. Just be careful. Just be careful and work it out. Now, as you're working that second bearing in, you kind of have a tendency to pull the shaft out of the inner race of the first bearing. So you have to kind of be careful of that and pay attention to what's going on. When you get done, the journal shoulder on the first bearing needs to be right up against that bearing inner race. So there's plenty of room for the pulley on that end. The other end, however, there's quite a gap between the journal shoulder and the inner race, which is okay. Once you're sure you're not going to take this thing apart and you're going good, go ahead and torque down these set screws on the cone pulley. And go ahead and let them bite into that shaft. And then there's also a lock nut that you'll want to tighten down, make sure that gets nice and tight as well. Now you can put on the flywheel pulley. And I've used a little bit of Loctite here just to kind of take up any slack that might be left. It's a really good fit though, it's a tight fit. And give you some lubricant for when you're sliding this pulley around to find that hole and line it up perfectly. Once you get it lined up, slide the taper pin in, and then put some blocking underneath the pulley. So when you pound that taper pin in, you don't put stress onto the bearing. Line it up so you get a good shot, and then use a big hammer to drive this home. You're better off with a bigger hammer and a couple of blows than small hammer and lots of blows. I have a bit of a confession here in full disclosure. This is one bearing that I forgot to put the blocking in. And when I seated that taper pin, you can see I distorted the casing on this bearing. Now, I probably didn't hurt it, but in good conscience, I couldn't leave it in. So I had to replace it and do it over again. Everything's nice and straight and looks good. Now that you have the pulley on, you can go ahead and tighten up this nut to take all the slack out of the shaft. Basically, just kind of work it until you get it as tight as you can without any noise, or tighten it down until you hear some rubbing and then back it off a quarter or half turn. You'll have to mess with it for a while, but try to get it as tight as you can with no noise. And don't push the shaft out of the bearings, or make sure everything is lined up like you want it. Once you have the first nut where you want it, then you put the second nut on to secure both of them in the same spot. Now I had to use a little bit of a clamp here because I didn't have a wrench that was thin enough to grab that nut and be able to turn the other one, but this worked out okay. I was able to get it tight enough. You can hear a little bit of noise, one slight tap. Now it sounds good. All done, nice and straight, no noise, just like you want it. This is the motor mounting plate where the motor goes. Pretty simple. And I do notice, though, just for interest, is that there's two sets of mounting screws. These are the screws that are used for this 13-inch, but I can only assume that this same plate was used for a larger lathe with a bigger motor. And these are the ones we're going to use today. Put the motor on, put the motor mount screws in with their appropriate washers. Put in the belt tensioning stud and the nuts and washers. You got to put this thing in first, otherwise you're not going to be able to get it in after you put the shaft on. Slide on the motor mounting shaft. It's a tight fit, so you got to have everything lined up real well. Put a little grease on there before you do it, because that'll never be lubricated again. Set screw goes in, and then there is a small hole in the shaft to accept the set screw. Nice and tight. Now the motor pulley that was on this machine is not the original. The original has some set screws. This one has actually a wedge. I'll replace it later. Now you can line up and literally line up the pulley on the motor to the pulley on the shaft. And you adjust the motor pulley to get it there. Slide the belts on. And then you can tension the belts with the tensioning device and lock it down. I put power to the motor and crank the VFD up to 120 hertz, which is running the motor twice as fast as it'll ever go. And the thing sounds good, it sounds smooth, almost no vibration, so I'm happy.